So welcome back to my channel. In this video we are going to solve the maximum subarrays problem through Kadane's algorithm. Okay. Seen different types of techniques to solve this problem. First method that we have discussed is brute force approach. Then second method we have sum, and now this is the most optimizing algorithm to solve the maximum subarray sum. So let's start. So before understanding the Kadane's algorithm, so take an small maths. Okay. So if we add a big number, a positive big number, plus a positive small number, so what will be its output? Its output will be positive. Okay, so this is big number and this is small number. So next, if we have big number positive and the small number is negative, then the output will be positive only. Now if big number is negative plus small number is positive, then the output will be negative. So this is the basic rule of addition and subtraction in our mathematics. The Kadane's algorithm says that if two numbers addition is negative, then take it as 0. Okay, so the negative number will be considered to be 0. Okay, so we have to focus on this only. So if output is negative, then consider or take it as 0. This is said by the Kadane's algorithm. Here note, if the output is negative, then consider it as 0. Okay, important note here. Let's take an example. I've created an array and variable. I will take here two variables, current sum and maximum sum. The current sum is initialized with 0 and the maximum sum is initialized with -infinity. Okay, to traverse through this array one by one, and let's check. If the addition of two numbers is negative, then consider it as 0. So current sum and the maximum sum. So this is initialized by -infinity and current sum is initialized with 0. If we trace the array, and if the compiler is here and the addition will be 0 minus 2. The answer will be minus 2. Then we will consider it as 0. What will be the maximum sum? The maximum sum will be if current sum is greater than maximum sum, then maximum sum will be current sum. Minus infinity is less than the 0. So 0 is current sum and minus infinity is maximum sum. And as we have discussed here, if current sum is greater than maximum sum, then current sum will be maximum sum. So we have here updated the maximum sum. Now the compiler will go to next element. Now it will compare 0 minus 3. Obviously the answer will be in negative only. Then again the current sum will be 0 and the maximum sum will also be 0. So we calculate the current sum as current sum equal to array of I plus the current sum. Okay, so this way we can calculate the current sum and this way we can calculate our maximum sum. Okay. Now the compiler will go to next line and the current sum is 0 and the array of I is 4. Then 0 plus 4, the current sum will be 4 and then the maximum sum here is, so here current sum is 4 and maximum sum is 0. So it is current sum is greater than the maximum sum, then maximum sum will be updated and it will become 4. The compiler will go to next element here and then it will add 4 the minus 1. The current sum will be 3 and the maximum sum will be as it is because 3 is less than 4 only. Then the maximum sum will be remain as it is. Then the compiler will go to next element and it will compare. It will add. Okay, so current sum is 3 and current element is minus 2 and then it will be 1 and the current and the maximum sum will be 4 only, so it will remain as it is. Then the compiler will go to next element and it will add. Okay, current sum is 1 and array of I is 1, so 1 plus 1 2 and it will obviously compare and maximum sum will remain as it is. Then the compiler will go to next element and it will add. So the current sum is 2 and the array of I is 5, so it will be 7 and it will compare. Now is 4, maximum sum is 4 and current sum is 7. Obviously it will gets updated and current sum will become 7. So the maximum term will be become 7. Okay. Now the compiler will go to next element and it will add. Okay. So 7 and minus 3. So 7 minus 3 will be 4. The current sum will be 4 and the maximum sum will be remain as it is, because you will compare and 4 is less than 7, though it will remain as it is. So we have to return this maximum sum. See, so simply we have to print max dot sum and we will get as 7. This way we can find our maximum subarray sum, and let's see in our practical session. So let's start with a demonstration. So I have created a class called demo, and in that I have created a main method. Now I'm creating an array. Created an array. Now I will create a function to public static. So the return type will be obviously integer and the name will be find max sum. Okay. In that I will pass the parameter as array that I have created. Now I will create an variable and maxsum, and I will initialize it by minus infinity. Then I will run a loop for int I is equal to 0. I should less than array dot length, and I will get updated. Now in that I will create an variable current sum and I will initialize it by 0, and here I will create a loop for int j is equal to I, and j should less than array of length, and j will get updated. Now I will calculate current sum. So it will be current sum is equal to array of j. Okay. Now I will update the maximum sum, and it will be maximum of current sum and the maximums. Okay. And the current sum, whichever is the maximum, it will add it into maximum. Okay. Now we have to simply return the maximum. Okay. Now I have created an function for calculating the maximum subarray sum. Now let's call the function. Okay. System.out.print subarray sum. So I've called the function here. Okay. Now let's run the code and see what will be the output. So the output that we gotten as 7. Okay, as we have dry run the code. Okay, so this way we can calculate our maximum subarray through Kadane's algorithm. So Thank you for watching this video.